So I'm Talfao. I'm founder of CODESPECT, Cairo and Solidity auditor. I learned most of the Cairo in Netherlands, where I work as an auditor, and I'm one of the main contributors to Cairo smart contract hacking course from Journey Time. And I founded CODESPECT. So CODESPECT is my company, established like I think in Q4 last year. We focused on Solidity, Cairo and Rust audits. We also offer pen testing services, and our biggest client so far was Redstone Rackles, but it was Solidity audit, not the Cairo one. But currently we now mostly what our current flow are the Cairo audits. I hope more reports will be published, go public soon. Okay, so let's dive into the Starknet. So Starknet is layer 2. So that means it's layer above the Ethereum. And one important thing you need to keep in your mind when you are auditing Starknet or when you are interacting with the Starknet is that everything is like smart contract. Yeah, there's a native account abstraction, so even your wallets here is on Starknet are smart contracts. This is very cool. For example, what you can do is when you are performing swaps, so in EVM on, let's say, on Ethereum, on like layer 1 or Arbitrum, Optimism, etc. You need to, when you do swap, you need to approve your tokens and then perform the transaction of the swap. And that is really, I don't like this user experience. And on Starknet, when everything is smart contract, there are like multi-calls. That means you can execute more calls, I don't want to say transactions, more like calls in one transaction. So you can everything do it by signing one transaction and you approve it. If you perform the swap, it's very cool. So something you maybe we heard when you go to Starknet are the wallets Argent and Bravos. And also as there's a native account abstraction, you can also involve like two-factor authentication. So for example, in Bravos, you can initiate a transaction in your web browser and you need to like, confirm it in your mobile with a fingerprint or face screen. Something like that. It's very cool. Another like important fact is that gas can be paid in ETH and Stark. This is just like another information about the Starknet. And also the paymasters are allowed. So there is like another kind of contracts you can maybe find out and start it.
Just one phantom. It's really interesting that you can pay gas both Ether and Starknet. Not a lot of layer 2s are implementing that.
Sorry, can you repeat?
Yeah, it's not very interesting that you can pay your gas with and with Starknet tokens because usually layer 2s are not implementing that.
Yeah. That's true. And currently there is like no mempool, and it's important for you as an auditor because so far there should not be. I'm saying should not be because I'm not 100% sure. It's always a question. Front running should not be possible. Yeah, but because there's no public mempool, you should not someone front run you because we have sequence and it validates the transaction one by one.
Oh, front run.
Not like basically.
Sorry, perfect, man.
Yeah. Let's continue. Another thing which is kind of native in Starknet, it's upgradability. You have like kind of low-level code, or it's called Cisco, which allows you to upgrade the code of the contract. You of course need to use this Cisco in your contracts, but we know from Ethereum, everyone now uses kind of like proxy patterns. Yeah. So this is like better way how to do the upgrades. It's easier to implement it and it's also safer. But again, you need to like take into account like what is the purpose of the contract, that the upgrade doesn't break the original context, and like the storage, etc. So there are two things, like you have class in Starknet, which is like really the code, what you are writing in Cairo, you need to define it in Starknet, and it is defined by, or like it's referenced by its class hash. So when you like define it, some compilation, and its hash is then like, let's say, put it to the Starknet, And also this kind of solves a problem when you have like ERC20 token, which has the same code. And on Ethereum, you deploy the same code like so many times on the blockchain. And here you can do it just once, yeah, because you will just define the class which is already present on the Starknet, and you will use this class for the like instancing, for deployment of your contract. And the contract is really the thing which has the storage, which is influencing the code of the class. Another thing, I'm kind of like just mentioning some point, because there are a lot of stuff, and or about each of these we can have like a single presentation or a single talk. So it's just more like an introduction here. So we have something called like messaging, or I name it the Starknet messaging, because as it is layer 2, you need to somehow be able to communicate with layer 1. And there is like messaging mechanism which involves like submission of message on L1 or L2, and there is again some, let's say, centralized oracle, let's say it's a sequencer, what kind of execute or submit the message on the layer 1 and layer 2, depends on the direction. I will also go to this more in detail in demo, where we show how it can be implemented. So it's really like just to have this introduction about this kind of stuff. But it's really like important part of layer 2, yeah, because you need to somehow communicate with layer 1. There is one thing what I added like a few minutes ago or few hours ago to the presentation, and that is like first hack happened on Starknet today. It was a zkLand, what it was landing protocol, or it is landing protocol on Starknet, one of the top 5. It has, I think, more than 10 million TVL, and it was hacked, and like 3,300, I think, ETH was stolen, so almost 8 million. So that kind of could be like a push for all of us, that maybe Starknet security demand will be increased, because these kind of infos, force the protocols to invest more into the security. But it's of course like not a lot of information. Yeah.
Yeah, but it took a while, right? I mean, most of these layer 2s have been hacked way earlier. So I think you are completely right. This will increase the demand. So it's good that everybody's here listening, because that's a lot of knowledge.
Yeah. But of course it will like more in future learning that. So let's go to the Cairo. There is written Cairo 2, and the reason is simple, because previously there was like Cairo 0 version, and Cairo 0 was like really awful language, and it was not that much readable, and you still can find, I think, some contracts developed there, even though this is now like deprecated, but not the newest one are developed in that, because Darknet will like there was an upgrade which kind of like, let's say, making all the Cairo 0 contracts not working. Yeah. But you can find still like Cairo 0 in some like ZK stuff, which is more like different from Starknet. Yeah. Also, it's not like linked with the Starknet contracts now.
I remember that back in the past, people were talking about how complex was, developing for Cairo 0. And
Yeah.
thinking about Cairo 2, you think that they improved that a lot?
Yeah. Now the experience is way better, because Cairo 2 is more like Rust. Yeah, it's Rust based. What I've seen also so far was some Sway language. And it is like really similar. Yeah, these kind of two languages. So it's like also more similar to Solidity. So it's really pleasant to, let's say, audit this kind of language and also develop. I would say that Solidity experience in development is still better, but it's good. So Cairo 2 is used for Shark and contracts now. If you are interested like to see some open source projects in Cairo 2, go to OnlyDust. It's a really good platform. You can get like paid for some contributions to open source projects. And you also can read like a lot of Cairo code there. Yeah. And also there's, I think, Stellar and other platforms, but Cairo is kind of like well managed there. Yeah. And another thing, like I'm just mentioning here, I think you will be able to download it on your own. For Cairo too, you need like Scarb if you want to compile it. Also there you specify like the version of the Cairo. And also Starknet Foundry. We all know Foundry, yeah, from the Solidity, from the EVM, which is for the testing or also deployments. Similar thing was developed for Starknet, and it's really cool. It is now really great experience when you test something, because in Cairo 0, you, for example, were developing tests in Python, yeah. And like I'm not saying it's bad, but it's, you know, you need to do the language switch, and now you can still develop. Let's say in Cairo, it's more like Rust, yeah, when you're writing test now, which is cool. Uh, Now I have like quick demo how some smart contract looks like for example a token. So give me a second. I just will open it here and try to share the screen of the VS Code. Okay. So it should be here. The code. Is it okay? And also the size?
Yes,
That's
perfect.
Yeah, because I have like 2K monitors, so it's sometimes the problem. So, if it's okay, let's just quickly see like how the code looks like. So you have like it's token contract. Its name is token. Like there's like keyboard mode, so which is like a module. If we go to the Rust thing, to the Rust language, but this macro is important, which define what is like Starknet contract, and compiler knows that he needs to like compile it as a Starknet contract. So this macro is like the most important part. Um, then we have some imports, so we maybe seen this kind of thing in Rust, also in Solidity, but the imports are made a little bit different. And then each contract has its storage. So this is like very good that in Cairo you see exactly what are the storage variables, yeah, because it has to be in this defined in this struct. And again, this macro is important. This name could be different, but it's the let's say the macro which is defining what storage is this, or what struct is the storage, yeah. Then some events, yeah, let's skip it here. And then we have the constructor, and after that we can have like the functions. Maybe I will show it soon. Yeah, so this is like really simple token contract, and but you see that there is like not many stuff, yeah. Even though it's like token, we are missing here like transfer from functions, etc. Yeah, there is no inheritance in the Cairo, but there is something called component here. Like when you are building also the Rust, you are kind of building from modules, yeah, from, I don't want to say they are not named components, but it is like building blocks. You are building above one another, and you are creating like the protocol or the program from this kind of modules.
One question on line 7. So there we have path, the ERC20 component. So I imagine that's the path for the component. And then we're setting up the storage as ERC20, which I imagine is a variable inside the component itself, right?
Yeah, yeah, it's like, oh, I want to go through it because I also want to like show you a component. So here we like define that this contract is using a component. This is like the ERC20 component, which is again some let's say module from the Rust language. We can see it here. I will go. I think I have it also here somewhere. Yeah, it is here. So here you can see, you know, again macro for the component. So here is some ERC20 component what we reference in the path. Yeah. And then we have a storage. Here is more like the name of the whole component we will like kind of use as a, let's say, as a reference in our contract, because here you see here we've defined it as a ERC20, but then you also reference it here when you are using the functions from the component. You need to use the name you are like defining here and here. Yeah. So it's kind of like the key point. It's with working with components. And also here you define like that you are using the storage of your component. You also need to define the sub-storage macro, which again referencing that you are using the storage of the component. Yeah, and you are like again building this stuff. And let's show a little bit about this starter command. This is developed by OpenZapply. So they also invest some time in the Starknet, like create like, you know, in Solidity you have these open Zeppelin contracts, so you have like Cairo version of it, which is really cool. Really cool. That like open Zeppelin is investing time in this ecosystem. So again, you have here the storage and the component, which then when you are initializing this, will kind of, you can imagine that this is kind of like here, yeah. When you reference the storage from the component, but that's the reason why we are using the component storage. Then what is like really important part is this implementation. You are implementing like a trade. Trade is, we can here imagine it as a interface definition. Yeah. Because you can see that there is like implementation of ERC20. You define that there's variable influence the state of the contract, also of the component, is implementation of something, and of what you are referencing here is the interface ERC20. So if you go to ERC20, I probably don't have it here directly. I want to show it to you here. So you can see that here it is the interface and already defined as interface in the Starknet, like a language, sorry, in the macro. So you already have a Starknet interface here, and then you are implementing the specific functions. So you're implementing some view functions. The difference how you can see or how you can notice what is view and what is like a storage changing function is the first the sub parameter. When it's view function, it's just like a sub, and it is like the snapshot of the storage. Here is a component state, and when you have a changing function or like a, you know, storage changing function, then you have like a reference to the storage, yeah, to the here is the called like component state. But for example, if we go to the token, you can see here is like a contract state, yeah, not the component state. Yeah, so you have some functions, and important thing here that when you use this embeddable macro, you can then reference in your token or in your contract, even our token contract, the implementation, and via this API interface, you expose the interface to be called publicly. Yeah, so it is like in the Solidity, we use the external keyboard, yeah, for each function to be able to call. But here you define the trade, and then the trade you can expose or sorry, the implementation of the trade you can expose to be XO. Yeah. I think any questions here so far? It was just like I know many information.
No questions for me. Yeah, let's keep on.
Okay. So we'll just go in my presentation, and I was on because here it was more a demo for the language. We already have like 20 minutes past, I think. So go to the
Feel free to use as much time as you want.
okay. That's cool. I want to show you the bridge thing. You probably heard about this bridge because it had a contest on CodeHawks. It was called Ad Bridge. And there is like, I want to show you how this messaging works in general. And so, and also there are some issues connected to that. I will mention them later. But generally, you send some message. You use like the Starknet contract or core contract, which is deployed on L1. This is like, you also can see Solidity code. So this is like interaction from L1 to L2. Yeah, you are sending a message from L1 to contract to L2 contract. So you define like who is the like your target on L2. You define also like what function should we call. It is this like L2 selector. So again, we also use selectors here for like the function names, function referencing, and also payload, which is like all all the parameters. I don't want to go much in detail here because you can see it's like a lot of like hidden stuff which we cannot see. They also do some like packing of data because they need to pack it with the same data type that which is used in Starknet. So use this like send message function, which is sending the message, and on what is happening on L2 part is, so we have Ethereum here. We need to find again bridge. In L2, what will be like called by sequencer, or on L2 part is a function which is marked with L1 handler. Of course, you need to use this withdraw auto from L1 as a selector, or like you can create a selector from this name in L1 contract, but this will be called, and here it do some logic, yeah? But that is what is like called on this side. And again, you also can initiate L1 interaction from here, and there's some syscall, which is like send message to L1 syscall there. So again, we can see that like the low level calls kind of have the good naming, yeah, to understanding what is happening. So for us as an auditors, even though you don't have much experience with like Cairo, it's not that hard to also read like the Starknet or Cairo specific stuff.
Yeah, I understand.
The namings, it's okay. And even like when I read first contract, what I read was from Avnu, what was like what is the biggest aggregator on Starknet, which was audited by Nethermat. So even though I had like so little experience, I was able to understand what is like going on. Yeah. It's just like you need to spend just some time, but it's not like you would really need to learn a development in Cairo. Yeah, something like that. You can just it's just reading all the code, yeah, of the Rust code, let's say. Yeah, so you again see you need to specify the IOM1 address and again some payload. Yeah, so it was just like a quick intro, and I will show some possible vulnerabilities, not here because this should be a fixed version, but possible vulnerabilities what can arise later. Let's go back to the presentation. Okay, do you see the presentation again?
Yeah.
Okay, so go to Cairo auditing. Here, we need to take into account that it is still like layer 2, so the, let's say, virtual machines should be kind of like similar. So there are not that many differences if we compare it with the Solidity auditing. Also, if you like understand the language, it's kind of easy to like audit that code base there in Cairo. Because for example, in Solana, you have like these different account models and everything like that. And here was not that big problem, yeah? Because even though each each wallet on Starknet is contract, you still like kind of work with it as it is in Solidity, yeah, or in layer one. So it's not that a huge problem. So we still find similar issues as on Solidity here. And mostly what is like most common are the logical stuff, yeah, or like something specific for the protocols. But let's wait. So let's first talk a little bit about reentrancy. Important thing. It still occurs, yeah, sometimes, even though I think developers now are more aware of this kind of attack. But on Starknet, you prevent one potential vector, and that is like there are no native transfers, yeah, because ETH is just the ERC20 token, even also Starknet token is just ERC20 token. So there is no receive or fallback function which would call or can create a callback. Only way or only parts where are there some callbacks is safe transfer from ERC7 to 1. Yeah, because you check if the like contract can accept the NFT, so we need to give you some like answer. And also some contracts could have custom hooks or custom callbacks. So there are the places where you should look for reentrancy attacks. And general good practice is always to follow checks FX interaction pattern. Yeah. At first you perform conditions, then you update storage, and at the end you interact with the external contracts. Arithmetic overflows. Still possible on Starknet, but just for one data type, and that's called felt 252. Important thing, which also helps you, for example, in the messaging part, is that everything in Cairo is like felt. Every data type is built, yeah, like from the felt is created, let's say, the storage layer on site, and it is like the number there is same as you have like even 156 is the number of bits, yeah, which are defined in the storage. But you also have the like the let's say the wrapped data types over the fields, and that is the integers, unsigned integers, booleans, yeah. And for the integers, unsigned integers, you have built-in protection against arithmetic overflows, and is generally used. The fields are used just in case of some messaging, or maybe in some very old contracts. Yeah, I still seen something like that, but usually you use the UNs or sorry unsigned integers. Yeah. Any questions here so far? So can I? Okay. So yeah, I go back. Then again, you can have open low-level calls. I've seen so far just one vulnerability with it. So far, but let's see what will happen in the future. If you have open or no access control above the function which is using replace class Cisco, that's critical problem there because you can upgrade the class, the code of the contract. Then you have something similar to the call in the Solidity that is called contract Cisco. So if there you, for example, you can put whatever function name, or here it's like selector, and whatever target, then you can, for example, approve ERC20 contract to some arbitrary address, and you can steal the tokens. Then you have library call Cisco, which is like a delegate call. But here you can kind of change the attack when you find open call to library call Cisco. Then you can also upgrade the contract, yeah, because you can chain to some function which is like using the replace class Cisco, so you will chain it, and you can have like a attack vector for upgrading.
Awesome.
Then again, I will mention oracles. which are which need to be used always in DeFi or closing contracts, because we need some pricing in general. But this one bad practice that I simply find in Starknet is that many protocols use like custom oracles. It is like something what they control, and there is like a, just some access control which allows admins to publish prices. So be careful about these kind of protocols. I will not mention their names, but just be aware if you are using them. It's really a huge centralized risk.
Yeah, someone can just change the price and some bad actor can get access to the team. So this is really weird.
Yeah, yeah. But we have Pragma on Starknet. I think there are some other providers, but mentioning Pragma because that is the most well known in Starknet. Less, it's something like chaining yak. So we also check for staleness. So with some best practice Pragma docs advices, and also something called like number of sources. So let's say that is like a number of data publishers. Yeah. So in general, they can have in the docs like what should be at the minimum, what you should check, and if it's not done, then you should not accept this price. This is a code from Opus, standard protocol, and that had competition on code for RNA last year.
Also, are the contracts sorry, Matt, can I verify? Are the contracts open source? Can I verify the code?
Yeah, the Opus contracts are open source, or at least the code for Arena repo. Yeah, it's open, so you can read the code base them for the Opus contract. And Opus is kind of cool. It's something like MakerDAO, yeah, something like that. So it's interesting code base to learn from. Then we have a visibility of components. I just put it here because it's kind of like interesting, maybe more for developers to just prevent this issue. It generally don't happen that often because you can find out this by easy test, yeah, by single test. And like it is that we think that sometimes you forget this ABI macro above the implementation, yeah. And that means that you will not expose the external functions. Yeah, I seen it once. That's the reason why I put it here. Because it's kind of funny what developers can forget sometimes, even for audit. But there's also like another thing, and there was like a huge discussion in the past around like uppercase and snake case naming convention for like also storage variables, but mainly for functions. Yeah, function X. And there was like uh, a problem in some protocols when they use like a uppercase when they were using or some contracts, but like the contract itself used like lowercase, yeah. But because they use like mock contracts, they forgot about that, and in production it will not work. So again, this can be fine by testing, yes. But now most of the
But it works. That's it. Like everything compiles and because it seems like it should be carved.
yeah, it can be like it can be compiled, or it should be, or I was not testing this in the latest version of Cairo, but there is like a huge development in that. So sometimes edge of us even like allowed to compile it. Um, yeah. But the important thing what I also said was about the naming convention, and that I want to continue that. Hopefully now you have this kind of like mixing implementation which like use both naming, yeah. So you even have like transfer from, let's say, in the uppercase format for this ERC20, and also in snake case format, yeah. So now it cannot happen that, or it should not happen, for at least ERC20 tokens, that like one or the second interface will just work. Now it should work both if you are using this mixing implementation. That's for like OpenZeppelin tokens, but you still can find contracts which forget to use the correct naming convention, and the protocols reference it in the wrong way. And I think just to be clear, the snake case should be used. Yeah. It is like focused on Rust, so snake case is the like agreed naming convention for the Cairo development. Then this doesn't happen now so much because we are more in development in the whole Starknet ecosystem, and that are like math issues. There were like what we're doing protocols in the past, especially at the beginning, like of the Starknet Cairo 2, let's say, also in Cairo 0, but also in Cairo 2, is those they were creating their own math functions, even like for PO or POW, I think is maybe the pronunciation, sorry for that. They created their own, and there were some like edge cases which were not handled. So you generally can find these kind of issues in the reports. I think Nethermind reported some of the issues with that in some protocols. Also, Cairo Security Clan. Hopefully, we have not found many issues with that in CodeSpec. Because we now develop more like novel products which already use like known libraries or used libraries, which were developed during this time, on Starknet. So it's now getting better, but still be aware of like math functions. I don't mean like for the calculation for for Uniswap construct product or something like that, but more for like these like PO function or squared root or something like that there. Some of this kind of stuff.
Awesome.
Then bridging issues. Yeah. That's the thing why I wanted to show the bridge. I think, and I will also go to the bridge contract later to show that they are doing that in correct way. Yeah. Or at least in some working way. High conversions are an important thing. Because on Starknet everything is spelled. Yeah. And on Solidity, I think everything is uint 256. Yeah, I think it is like that. Also, sometimes they forgot to implement like canceling of messages, because what can happen that if you initiate or if you send message from L1 to L2, on L2 could be some error in the function, which is marked with the L1 handler. Yeah, there can be like, for example, the bridge or the contract that is paused. Yeah, so if it not execute, let's say the message, the from L1. So on L1, this message will remain like unused, or let's say unprocessed, because on L2 it will not be executed, but it will not be initiated again by the Starknet sequencer. Yeah. So in L1 contract, which is using this messaging, you need to like be able to call something. It is called a cancel message, and you define the hash of the message. So you need to involve this function inside your contract, or sorry, implementation. And also there is like access control for L1 handler. So you should check always if like the correct source is initiating the message. Also it should be also in L1 and L2, like vice versa, yeah? Both directions. Let's Mirrors show it in the bridge contract. So that's about bridging issues, just shortly. And now the most common, I generally say it's logical issues, but it contains like more stuff. It is like wrong storage updates, incorrect math equations. So that is, for example, if you create like the wrong constant market product, something like that. Or you have some context problems, something specific for the protocol. Yeah, there was like in DeFi, what usually is a problem. For example, if you have lending and borrowing protocol and you involve some pausing mechanism. So imagine the situation when you pause repay function, also borrowing function, etc., but you will not pause the liquidation function. Yeah. So that's generally provides very interesting. Yeah, that happens. I think also there was a interesting. It was not about like the Cairo, yeah, about it was about the Solidity, but Dacian, that this I don't know if I pronounce his name correctly. He created a really nice blog post, yeah, about the lending and borrowing issues, and that that happened in this kind of problems. Any questions so far before I dive into the code?
Let's go to the code. Let's switch to the code.
Okay. So let's again share the screen. So let's I have here protocol. I have here few so the bridge again. So I also want to go there if we have time. Also this TPA. Let's go here because it shows it's not here more like about the auditing, but how like development could look like from the sense of components.
Just one
So
one thing
the,
though, want to tell you is that I think you're still sharing the screen with the pro.
oh, okay, yeah, sorry,
No problem.
sorry for
So it's back.
hey. Yep. So your server fig. Oh, but let's start with Dojo. Let's show some vulnerabilities. Yeah, that's always interesting. So this Dojo is uh kind of most vulnerable, most used. I would say one of the products on Starknet, and because this is a gaming engine, yeah, it is like allows you to create blockchain games, yeah, on Starknet. It's kind of like cool. And this is like really old version. Also, like the Cairo thing, what is used here is a little bit old. Uh, I think this version is almost 2 years old. Yeah, maybe 1 year. But still, the code is a little bit same. Yeah, written like actual for us. Uh, and and I would say sorry, it is less, and it is 1 year old, not 2 years, 1 year, but still kind of active. So, uh, how I usually approach the auditing in Cairo, yeah. So usually you have like a lot of. I'm always trying to be the most effective, so I usually like ignore this kind of long implement like defining of interfaces, yeah, which are generally sometimes they are in separate files, sometimes in the same file because you define the trait and which is then implemented in the protocol. I usually try to first go like through the main flows and try to understand like what is happening in the code. Again, what you can kind of ignore is the event stuff, yeah, which what you can see here so far. We just like Cairo code is sometimes very like full of many like nonsense code there because it's like it's a Rust, so you can see that we can skip just like 100 lines almost
Oh my god.
to go to the storage. Sometimes what is important to see is the imports and maybe some constants. So constants are generally defined, let's say, from the it can be everywhere, but generally or not everywhere, but everywhere like outside of the trace or implementation of the trace or the storage. So it's generally under the imports. Yeah. And we also see here that like there are so many imports. Yeah. There's like on the first side you can see like, oh, that's awful, I will not read it. But you can just like, skip it most of the time. Yeah. Just blow at it. Scab. Sorry.
What mode code do you use?
Yeah. So you can check generally the storage so that you know like what kind of storage variables are here. Here you can see that my VS Code is saying like this is a deprecated feature, and the reason is that legacy map is now not used for mapping in Cairo. In current version of Cairo, it is something different. It is this map thing. But here you see it will not work because we use old version. Yeah. Um, but it works similar. Yeah? It's mapping, so we know mappings from Solidity. Yeah, so it's there's a little bit different way how you approach that, but so in general sense it works same. So what we also can see here, and here I go more into the detail. When you are writing to the storage, you are always referencing the state of the contract, which we know is the first parameter is the sub. Then you use the first name, and then you use this word write to write the storage. And mappings could be right like here. Now in the new version, the syntax is a little bit different, but this still can be used for some kind of mappings. Here what was generally happen, so this is like word contract, and that is like you can define some models and system programs. So we can imagine like Word is the game, game. Uh, I cannot now name some game, but yeah, it's the word of the game, and it connects models. What models should be like characters, yeah, or some items in the game, and then you have like programs which should be or system programs. It is how Dojo referencing them, and it is like the logic, yeah. So the movement, the attacks, or this logic in the games is just for that at least we know what we are looking at. Yeah. And there were like interesting issues. Okay, find it. There was also an issue in this functions and metadata, but let's skip it. What they use, what we will find out if you go to this code, is that you can register a model and you can deploy the contract, which is like the system contract, the logic in the games, for attacks between characters, etc. And what you can see generally is, which should be like a red flag, is that you have like two different entities. Yeah, you have models and some contracts, some programs, and they use some same mapping. Yeah, they use self-owners and self-ownership. Yeah, and usually this kind of thing, when you have like different entities, should be a red flag for you. And it's not just for Cairo auditing, it's also for Solidity. The problem was that here you like register the model. Yeah. If it's here, I need to a little bit go a little bit to the detail. So you use this class call here. Let's go. What is class call? Class call is using the call, which should be executor dispatcher, and we see that call is just the open library call, yeah, which is open delegate. And the problem here was because we know, let's wait, what is it? Models, register model, lot of code, yeah, register model. We can see if you go to the flow, so when you register a model, you define a class hash. So that is what will be like the code, what is executed on class, what is executed in that executor contract, yeah, in some executor contract, and it should return some name. So generally, what happens here, that what they were trying to involve is that they initiate to whatever class they should define a library call to name and report. So there should be some function which his name is like, I will put it here above, should be like fn name. Yeah, this should be like defined in the class hash you are calling. Yeah, if it's not, then it will not work. Yeah, it will reboot. So what will happen is that it will return the 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 the, the felt from the name function. Yeah, we can also see, or we cannot see, but it will go to the, when we go to executor, we see there is some keyboard unwrap syscode. What it generally does, it unwrap, let's say the output or the written variables from the function execution. Yeah, and these are, then we also see that this function call returns, and it is in the Rust syntax, it returns a span of file 252. Span is like array. Yeah, it's array which can be changed. Let's go to the workback. And the problem here was that you can put like whatever thing to the name function, yeah, whatever value, whatever return, because it will return some custom name, so you can return with whatever name, yeah. And the problem was here, especially because the name is then used as a key in the owner's mapping. And if you go to the beginning, there was something like in constructor, we can see that in owners for word, which is like the owner of this contract, some creator was put, yeah, which should be like the, let's say, some admin. Yeah, there's will be some admin address. So some admin is, and that reference in some access control in other parts of the code base. And I don't want to like spend so much time with that. This becomes me about the issue.
So for example, it's
Sorry.
or it's just don't worry about that.
Okay. So yeah, okay. So let's go ahead. So if you want to use the owners I use is here. You have this is owner function. So we check if some resource, what is in that example of the constructor, is the work. So word is it was constant, and what I remember, I think it was 0. But so the owner of 0, let's say, is some other, so germ mapping, some access control, and the is owner is then used, for example, in mhm. So for example, executor, yeah. So if you are owner of the word, you can set some functions. You can also update the contract, yeah. And you also can, there's some asset can write, which was used for like writing some metadata, yeah, how this like word can work. There's no lot of fans, yeah, because it was on-chain game, but it was still impactful for the game. So if we go back to the register model, so as you can return whatever name, and this model was not like registered yet, the word is just for the owner mapping, not for this models mapping, then you can just override the access control for the total, for the whole word, yeah. Because if the name return 0, what can be done because the class hash is arbitrary, then you can become a owner of the whole contract there. There was like a critical issue in this Dojo contracts. It's was it understandable or are missing some points here? Oh, it was okay. It's just so show that like usual issues again in Cairo auditing are like storage updates, yeah, storage write-up. And also if you remember, uh, as this class hash is again arbitrary. What you can do, even though it was like an impact for the protocol itself, but not for the files, etc. If you remember, when you use library calls, this call, you can do you see the call fraction now?
Yeah.
Because I see in this code some odd old picture. So I'm not sure.
See the powerful view.
Yeah. So even though entry point is not arbitrary, it was this name entry point, but class is arbitrary. You can even like upgrade the executor contract, yeah, because this is like library called Cisco. So if the name function, if your class hash upgrade the class, then this executor will get upgraded and the code will be changed. Yeah. So it was another issue found in Dojo. So be aware of this open low-level code, especially the library code, because you can just upgrade the contracts, which is not pleasant. Then I want to go to the bridge, so it was just like, if someone will be interested, I also can give you a commit for this dojo, which contains all these issues, yeah, and you can do some shadow auditing, improve you, but just don't forget to ping me. Oh. It's public repository, so there shouldn't be a problem. Let's go to the other bridge, which it should be fixed, but I want to show you what they are doing correctly here. And if you are developing bridge or if you are auditing bridge, what you should check. Yeah. So the usual thing what we need to check is that on L1, when they are, for example, setting like what is the L2 contract address or selector for the function, you always need to check if they use like Starknet address. Yeah, they use some Cairo library here. We can go here to it. And yep. Here's some Cairo library, and you see that they are using some wrapping for felt, also for Starknet address. Also, they serialize UINs to these felts. Yeah. So that you always need to, yeah, we don't want to go much in detail. It will take a lot of time here to understand how everything this works. But in general, if you see bridges, really focus on the type conversions, yeah, between the Starknet types, yeah, for Starknet address, for also felts, yeah, and then the different part, yeah, for from Starknet to like Solidity types. And so be careful about that. Also, check this part. Then what also was kind of its usual problem here is that you can define whatever message value when you are sending message to L2, and they are not refunding the message value. Yeah. So you really need to calculate it correctly and also involve some correct mechanism to check if this is like okay, if the gas is enough to execute the transaction. Also, if it's not too much that like a lot of ether remain in the contract. Yeah, I think but it's hard to predict. They don't have like exact let's say get function in the bridge part, yeah, or in the Starknet L1 contract. So this is harder to involve, but is another thing which need to be checked. Also another thing here, this is not EVM directly, so your L1 address it's not the same on the Starknet. Yeah, on Starknet you create different wallet, different address. So okay, you need to also handle this in their contract there, or at least in the front end. So be careful. We cannot use like just some one address. They're in the bridging or between the layers. Then there's an important thing, and that was about the cancellation I mentioned, and it is defined to two steps. First, the contract has to be able to request the cancellation on the message. So here they restricted to only owner. It generally makes sense. You also need to have access control for this because you don't want that if me as a user initiates a message which was not executed yet, yeah, because there's still some period for that, or there might be some error, etc. That some another user cancel my message. Yeah. So I only should be able to cancel my message. Right? Even though some contract is using that, I should be able to do that. And also if for example, this was breaching of NFT, so when they cancel the request, so then initiate the cancellation, there is some period, and after that you can call this cancel L1 to L2 message, and you need to evolve some logic. Yeah. So for example, when you cancel breaching of NFT, the canceller should return to you the NFT. Yeah. Part. If like Masons. Yeah. So and on L2 part, I just want to show that when you have this L1 handler which shown in past, it need to be put that this function can be executed by messaging system, the sequencer. You also need to check this, yeah, this like from address, because this is not like a custom. Yeah, the from address is the L1 address from which was initiated the message. Yeah. So this need to be also checked as some access control. That is L1 address is something you are storing in your storage. Some access control should be involved here. Yeah. Any question here about something about the bridging?
No, pretty clear, bro. Pretty clear.
I know I'm fast, but it's a lot of stuff, and you can do a presentation just about the bridges. But that's what I'm.
On YouTube, people will see this several times, or will have the time to catch up.
Yeah. So I'm just like giving that overview, and there's just a quick thing about the TPA. The TPA was some standard, kind of created on the Starknet. It is like the owner of NFT had account, like a contract, and only the owner of the NFT can like initiate the transactions from this contract there. So this is somehow like smart bullet, but it doesn't keep the standard of the smart bullet of the Starknet itself. That is again for for a different presentation, I would say. And it was more about the component stuff, what I want to share, how the development is usually done. So you see you have here some account, Arbitrary, it's called, and you see there's using so many components here. And this is how I would say a good development in Cairo look like when you have a huge project or a bigger code base. You should like split it to the modules, to the components, because it's also good for the auditors to read it. And there was something with a state where windows. Yep. So usually what you can see here is, for example, here we can check if like the signature is valid, or if some user is a valid signer on this account. And we can see here again that some component is used. So we go just to this component. We see it's again this component, yeah, because of this macro. And we can see like the function here. Yeah, for example, if it's valid signer. So it's easy here. Having here about maybe not this function. And was also they doing so here they are, for example, cross-referencing like another component, so it can be done via this get like a component that component, I don't know, dependency component, I think is that the exact name, and they can now reference our function from another component in this component there, because this is you need to have some workaround, to cross use the component functions in different components. Yeah. It's kind of complex, but it is readable, and I just want to show you that like you can have the audits or contracts which really involve the components, so it's really reasonable to spend some time with it. Yeah. So that was, I think, everything from the demo. What I wanted to show just as an introduction to Cairo security. And that should be everything from my side. I know it was a lot of information, but I hope it at least give you some introduction to this system,
Yeah,
our ecosystem.
really thank you. Like this was really insightful, and it shows several parts and several components of critical application like bridges, tokens, and really shows us that Cairo 2 is something that you can learn from. It's something, I mean, people in the past they were talking about Cairo first version and how hard it was, but I can really see like they've been working and improving it a lot.
Yeah. The code is like really readable, and I really, if you are interested in Scarb and auditing, just go there, just read the code. Even if you are Solidity scared, you can do it. Yeah, it's not that hard. Honestly.
Once again, bro, let's talk a little bit about code specs. So people that may hear us in the future can, if they need Cairo audits, they can talk to you.
Yeah. So if you are developing something, Cairo is generally good. If you will reach us, we focus on Cairo a lot, as we had this great experience, also for me from Nethermind, also from Contest and other parts. And now we are also auditing Cairo. Yeah, so we are getting more and more experience. Also, we are kind of elaborated in the sense that we know what is happening on Starknet. Yeah, Cairo language is getting new version every month. Yeah, so we also need to learn this stuff. What is new, and yeah, and we are also, I would not say we are hiring, but if someone from the auditing is kind of interesting to learn something about Cairo, maybe you can get internship in CodeSpec for some future Cairo audit. And then if you are good, we can maybe hire you for some other projects we will do in the future.
So that's very good, actually, for all auditors out there. There's an opportunity. If you learn Cairo, you're good at that, talk with Talfao, and then you guys can work together.
Yeah, we can, we are open to everyone who is good.
Brother, this is so much, once again, very insightful talk. There's any last message you want to leave people? Oh, one sec.
Yeah, I will.
Pals want to talk. Hey, Pals, also great, bro.
Yeah, good. Can you hear me?
Yeah, do you have questions?
Yes. Yeah, so I wanted to ask, are we free to DM on Talfao? You can DM me. Maybe better is Telegram. Uh, if you want some awesome challenge, you can find Telegram easily by my Twitter account. But also you can DM me in Discord. No problem. I will probably agree and get.
Awesome. Thanks. Thank you so much, Pals, for joining, and thank you for the questions. Go on, Monza.
Okay.
Oh, no, perfect. You can tip on.
Yeah. So my last message was kind of like, I would say Starknet is good. Even say someone says it's not that they're good how it was in the past, but the protocols are trying. There's some development initiatives. There are also some grants, so it's also good for developers. Even and also it's a first like may focus on developers or like the layer. Yeah, so we can easily get some grants there. I would not say easily, but maybe easier than in some other chains to build your idea. So it's really good. And also from the perspective of auditing, I would say like don't be stuck just with one chain or one language. We should be all, I think, chain agnostic, yeah, for the auditing. But of course we should like specialize on something, but it's just I would say always it's just a different code, what is or sorry, different language, but the reading is kind of the similar. Only differences or main differences which are the, let's say, the virtual machine differences, what is like Ethereum and Solana. It's like really a huge difference. What we need to like focus on when we learn the stuff. And for the auditing between like Cairo and Solidity, guys, just go to read Cairo and you will learn it, easily.
Awesome, bro. Thank you, Roger. Yeah, no problem. That was amazing talk. I want to thank you again. Everyone check CodeSpect. follow our friend Talfao on Twitter. I think his Twitter is Talfao1 is his handle there. And yeah, thanks for showing up. This will be on YouTube very soon. And it was a pleasure, guys.
Hello, Alex. Are you here?
Yeah, can you hear me? Hey, yeah, can you hear me? So sorry, I was just saying that was amazing. And telling everybody to take a look at CODESPECT. And thank you guys so much. And this will be on YouTube very soon, so you guys can check it out and watch again. And talk to you guys later.
See you, everyone. Bye.
Bye bye.